Okay. Hi guys. Good morning. Shall we start?
Yes, sir.
Right. Okay. So we have been seeing chemical kinetics, right? Okay. So I think we saw. I just gave you an introduction about order of reaction, isn't it? Right. So what happened there? So can someone tell me what are the two types of chemical reactions with respect to whatever we saw last class? What are the two types of chemical reactions?
Elementary and complex.
Correct. So we have something called as elementary chemical reactions and complex chemical reactions, right? So what is the difference in elementary and complex?
Single step reaction.
Okay. So elementary is going to be a single step reaction. The reaction has only one step. So example is your SN2, right? So it happens in a single step, right? Okay. So what is the specialty about elementary reaction? What can you comment on the order of an elementary reaction? I'm asking, how can you comment or what can you comment on the order of an elementary reaction?
Stoichiometric coefficient.
Correct. So in case of an elementary reaction, you are going to say you will write the rate law or R power n. So this n becomes the stoichiometric coefficient. If and only if the reaction you're talking about is going to be an elementary reaction. Okay. So what about a complex reaction then? What do you mean by a complex reaction?
Many number of steps.
Correct. So complex reaction is made up of many number of steps. So how are these each steps?
Each step is an elementary step.
Good, right? So each step is actually an elementary step, right? So I would say a complex chemical reaction is made up of so many number of elementary reactions, right? So many number of elementary steps are there. Okay, so then we spoke about order. Like basically we started with this. If you can remember, we started with something called as law of mass action, right? So law of mass action says that the rate of a chemical reaction is directly proportional to the concentration of the concentration of product of the concentration of the reactants raised to some powers, and those powers are what are called as order of the reaction. The sum of the powers are what are called as the overall order. So if at all I have one component having power x and another component having power y, so this x and y are what are called as order with respect to that particular reactant, right? And the overall order would be what is that, x plus y. All that we saw, correct? Okay. So next thing is I'm going to introduce you to a term called as molecularity, right? So first we'll take down the definition for molecularity. Okay, so there are how many people? There are 1, 2, almost so many people are there. Okay, how many of you are feeling sleepy, guys? I will completely understand. Okay, if you tell that you're sleepy, I will completely understand. But I want you to just wake up and at least tell me, sir, I am sleepy. How many of you like that?
Sir, it's fine.
Right. Okay, because I see only 1 or 2 voices talking to me. Other voices are actually very silent. Right. So, anyways, if at all somebody is waking up, don't be like, you don't know me. So out of nowhere, I'll ask, hey, Kailash, sing a song for me. All that is going to happen. Right. Right. Okay. So we are going to see a term called as molecularity. Right. So please take down the definition. It is the number of reacting species. It is the number of reacting species taking part in a chemical reaction. It is the number of reacting species taking part in the chemical reaction, right? So the definition is very simple, right? Okay, so for example, now, okay. Just a small change in the definition. It is the number of reacting species taking part in an elementary chemical reaction. Just include before chemical reaction. Just include elementary. We can speak about molecularity only for elementary chemical reactions, right? So it is the number of reacting species taking part in an elementary chemical reaction, right? Fine. So like if I'll give you an example, you'll get more clarity, right? Say I have reaction like this, a formation of ammonia, right? So how will I write the reaction? N2 plus 3H2 forms 2NH3, right? This is what is my reaction now, right? Fine. So if you look at this, I have 1 mole of N2 and 3 moles of H2 are reacting, and assuming that this is an elementary reaction, right? Assuming that this is an elementary reaction, so molecularity speaks about the number of reacting species. So how many numbers? 1 N2s and 3 H2s are reacting, correct? 1 N2, that is 1 molecule of N2, and 3 molecules of H2 are reacting, correct? So I can say that molecularity for this reaction is 4. 1 plus 2, or sorry, 1 plus 3 is 4, right? Same way if I have H2, 2H2 plus O2 giving 2H2O. See, please understand that I am not concerning anything about the product, right? I'm talking only about the reacting species. Reacting species, this is reactants. How many number of reactants are actually reacting in the chemical reaction is what is molecularity. So in this case, can someone tell me what will be the molecularity?
3.
Good, right? So you can see that 2 molecules of H2, 1 molecule of O2, so molecularity is 3, right? Okay, so why are we seeing about this molecularity is because it is going to have some kind of connection with the order of the reaction, right? So you can even make a note if you want, right? So the thing is, if it is an elementary chemical reaction, right? If it is an elementary reaction, the molecularity and order are same. So you can even make a note of this. For an elementary chemical reaction, molecularity will be equal to the order. Is it not? It's actually understood, right? I told you how order will work for an elementary chemical reaction. You can take the stoichiometric coefficient actually as the powers itself. This is what is happening here. Say if at all I write the rate law for this reaction, how will I write? R is equal to K into N2's concentration into H2's concentration. If it is an elementary reaction, I can write as H to power 3. What is the overall order here? Now here it is 1, 1 plus 3 again is 4. Right, same way for this, if I write R is equal to K into H2 power 2 into O2 power 1. So again, you can see that the overall order is 3, right? So again, molecularity and order are same. Again, this will happen only if you have elementary chemical reactions. Okay, fine. Now what happens, can I speak about molecularity for an complex reaction? The answer is no, right? You can even make a note of it. For complex reactions, molecularity has no sense, right? It's actually stupidity for us to speak about molecularity in terms of complex reaction. It doesn't make any sense, right? So molecularity is defined only for elementary reaction. So we cannot speak about molecularity for a complex reaction, right? That's what you need to understand, right? Okay, so this is about molecularity and order, right? Okay, so we'll move on. So we saw certain methods by which you'll be able to speak about the order of reaction, or the methods by which you'll be able to find the order of the reaction, right? So we'll see for more and more methods, right? We'll see what are all the other methods which are there, right? Which will help me to find the order. Okay, so one was graphical method, isn't it? Right? Fine. Let me see if you can remember. So through the graphical method, if I want to determine the order, tell me what will come on the x-axis, what will come on the y-axis. Sorry, x-axis and y-axis. If I need to find the order of a reaction with respect to the graph, yes.
Like on the x-axis, there'll be the constant of reactants.
Good, good.
And
so
on
in the
the
x-axis, I'll have
y-axis,
concentration. Y-axis?
we'll have the rate.
Good, right?
Rate.
So, yeah, correct. So, right. So in the graph, you would have seen that on the y-axis I have the rate, and in the x-axis you will have the concentration of the reactant, right? So it's very like it's pretty much understood what is the role your order is playing here, right? Order determines. See, please understand, if I write the rate law, R is actually directly proportional to concentration. That is understood, right? But if at all you want to get this perfect relationship, like if at all I change the reactant concentration, how the rate is varying, that is actually determined by the order of the reaction. Like if at all I just put this, always it is going to be a straight line passing to the origin, right? But actually it is not going to be like that. You always have some power, and this power or this order determines how the rate is varying with respect to the concentration of the reactant, isn't it? And you would have seen so many graphs, right? So for example, for a zeroth order reaction, right, you will see that the graph is like this, right? And this is for zeroth order. And if it is a first order reaction, you would have seen a graph like this, right? So from the graph, like obviously you'll be able to point, you will be able to plot the points and draw the graphs, right? By this, I'll be able to find the order of the reaction. This we saw last class. The second method was to look at whether the reaction is elementary or complex. If it is elementary, the stoichiometric coefficients are going to be the order of the reaction. So these are the only two things we saw, right? Okay. Now next method, right, is what is called as initial rate method, right? Okay. So what you can understand is, right, say if I write this rate law, R is equal to K R power N, right? So the concentration which you're using here, right, the concentration which you're using here, it can be dynamic. Basically, I can use the initial concentration. I can use concentration after the reaction has started also, say after 10 minutes, after 20 minutes, after 30 minutes, right? At the half-life, basically at the 50% completion, and say at the end of the reaction, equilibrium concentration. Any concentration I can put here. There is no restriction, right? But you want to find the reaction rate at the initial condition. That is, when I have initially some concentration of the reactant, right? Obviously, some rate would be there, right? And that rate might change, right? That rate might change because during the course of the reaction, the concentration of reactant is decreasing, right? So definitely the rate will also little slower down, right? So how to put it? Initially, when I have very high amount of reactants present, right, the rate will also be very higher. You can understand that at the initial concentration. So if I put R0 is the initial concentration, right? At the initial phase, that is when I have so much amount of reactant present, right, there'll be so much amount of reaction happening, and so the rate will be little higher, right? But as the reaction proceeds, the concentration of reactant will be keeping on decreasing because it will be consumed in the reaction, and so the rate will also vary, right? Okay, so let me put it like this. Okay, say I have, this is one iteration, right? That means I am going to say I have one reaction, right? So I am going to do the reaction in two ways. We can call it two ways. Or what I'm trying to tell is, I'm going to have two flasks, right? In the flask, I'm going to have the reactants to be same. Say reactants giving products is the reaction, right? So two things, two vessels in which the reaction is going to happen, right? Say in one case, I put R1 as the initial concentration, right? And say in the other one, R2 will be the initial concentration. Initial, I'm talking about the initial concentration, right? So R1 will be the initial concentration here, and this will be the initial concentration here, right? So obviously, what will you understand? Definitely the rate of the reaction in these two things will definitely be different, because here I have some other initial concentration, here I have a different initial concentration, right? So definitely the rate would vary, right? So by doing this experiment, that is starting the reaction with two different concentrations at two different vessels, same temperature. Okay, obviously temperature should be same, right? The reaction rate would be varying. For both these one, R1 and R2, say R1 and R2 will be the rate of the reaction, right? So there will be that we are going to derive. Actually, there is a derivation, but we don't need to look at the derivation, right? But there is a derivation by which you will be able to find what will be the correlation between R1 and R2, this concentration of reactants 1 and 2, and the order of the reaction. We'll be able to do this very perfectly, right? Okay, so what will we do is like this. I can straight away give you the reaction, right? I can straight away, or it's very simple, right? See, look at this. Okay, I'll rub this part. Now, what did I say? I have R1 to be the rate. Now, rate constant, what is speciality about the rate constant? Rate constant will not depend on the concentration. It's a constant value. The only thing rate constant will depend upon is the temperature. If I change the temperature or if I introduce a catalyst, then my rate constant might change. If not, no other factors will affect the rate constant value. Correct? Okay. So R1 is in the first flask, right? So that will be R1 power n. R1 is the first initial concentration. Say in the second flask, R2 will be this concentration, R2 power n, right? So now what I can do, I can just divide these two reactions and divide these two equations. So what will you get? R1 by R2 will be equal to concentration in the first flask, concentration in the second flask, the whole power n, right? The whole power n. So this is the formula which you have to remember. Right, R1 by R2, that is rate R1, small r1 by small r2 is equal to concentration of first reactant divided by concentration of the second iteration, the whole power n, where n is the order. Where n is the order of the reaction, right? So a lot of questions will come from this. You will be seeing a lot of questions coming from this particular thing, right? Okay, so shall we do some problems on this particular thing, what we saw?
Yes, sir. Yes, sir.
Yeah. Even if you say no, we will do problems. Okay, take down this reaction, take down this question. For the reaction, A plus 2B giving products, right? For the reaction, A plus 2B gives product. The reaction rate was halved. The reaction rate was halved, HALVED. The reaction rate was halved on doubling the concentration of A. On doubling the concentration of A. Right? They're asking you, find the order with respect to A. Find the order with respect to A. Right. So for the reaction A plus 2B giving products, the rate of the reaction was halved on doubling the concentration of A. Find the order with respect to A. Okay, so it's a very simple question. The same thing, this just formula if you use, it's done. Okay, so there in the reaction there are two reactants A and B, but in this particular question we don't have to worry about B because they're asking nothing about B, right? So you don't even have to include B in the rate law equation, right? So you can even write the rate law for this as K into A power concentration of A power n. Like obviously some B would have been there, right? But that is not what you are worrying about, right? With respect to A, only they're asking, right? So that's it. If I know this, the problem is done. Can you tell me the answer? What is the answer? What will I do? R1, R2, I can do that. Say first, this was the condition. This is what was there. Say now this I call it as R1. This is A1 initial concentration. Now what they're doing? They are making the concentration of A to be doubled. They're making the concentration of A to be doubled, and what they're finding out? They're finding out the rate is getting halved, right? So I can write it like this. So what is the thing in case of like if I can write it as half R1? Why half R1? Because the rate is getting halved. Half R1 is equal to K into, now what is happening to A? A is becoming twice. So again, if I write it again, can I write it as 2A power n? Right? So R is becoming half and the concentration of A is doubled. So I can write it as 2A. Correct? Right? So now what I have to do? If I divide these two equations, what will happen? So can I say that it will be R1 gets cancelled, K gets cancelled, A gets cancelled, right? Only N will be there, right? So how can I write this? I write it as 1 by 1 by 2 is equal to 1 by 2 the whole power N, right? 1 divided by 2 the whole power N. N is still there, right? So now this I'll be able to write it as 2 is equal to 1 by 2 power N. Correct? This 2 goes up. I'll have 2 is equal to 1 by 2 power n, right? So what should be n value here? What should be the n value? 1 by 2 power what is 2? Good, exactly. So here n is -1. That's the answer, right? So everybody understood. So whatever the method I told you last, like just previously, the same method only I'm using. So I have the first rate, right? When I have the only one time the concentration of A, they say that the rate is getting halved on doubling the concentration of A. So I divide these two equations and find the n value. N value is to be -1. We'll do one more question. First take this down, I'll give you the question. Right, the question. For the reaction 2A plus 3B giving products. So the reaction now is 2A plus 3B giving products. A is present in excess, right? For the reaction 2A plus 3B giving products, A, the reactant A is present in excess, right? Fine. When the concentration of B is changed from, 0.01 m, capital M, when the concentration of B is changed from 0.01 capital M to 0.04 capital M, the rate is doubled. The rate is doubled. Right? They're asking you find the rate law. That means you have to write the equation R is equal to K into A power something, B power something, that you have to write, right? So again, I repeat the question. For the reaction 2A plus 3B giving products, A is present in excess, right? When the concentration of B is changed from 0.01 m to 0.04 m, the rate is doubled. Thus, the rate law is. Find the rate law. Okay, fine. So we'll go to B later, right? Now look at the statement. They have told that A is present in excess, right? So whenever you see this term excess, something if one of the reactant is in excess, right? Blindly you can say the order with respect to that particular reactant is 0. You can just say that, right? You can actually logically understand this, right? Again, I repeat, whenever you see that a particular reactant is in excess, right? You can blindly put the order with respect to that reactant as 0. Why? Because if it is in excess, more than whatever is required, the change in concentration of that particular reactant will be very, very minimal, right? Say, for example, let me put it like this, right? So when I go to my hydrolysis of ester, right? I know ester on hydrolysis will give me acid and alcohol, right? So if I have R COO R dash plus H2O giving ROH plus R dash COOH, something like this, I have this reaction, right? So now obviously ester is there, water is there, right? So obviously in this reaction, what you see is that even though there are two reactants, right? Even though there are two reactants, only one of them is actually playing a role in deciding the rate of the reaction, right? And that one which is playing the role here is basically ester, right? The concentration of water will be very high. That is, it will be very much in excess, right? It will be very much in excess, and obviously you see that the amount of water wouldn't have changed much even after the reaction is completed, right? I'm telling, even after the reaction is completed, you will see that the amount of water is actually not changed much. So approximately, whenever you see something is in excess, right, you can understand that they will not affect the rate of the reaction. And obviously in which order means, when what is the order by which the concentration does not affect the rate? Only when the order is 0, right? So for this, I'll be able to write the rate law as H2O power 0. I can come like blindly write it whenever that is in excess, and RCOO R dash, and you can see this is actually a first order reaction, right? So you'll see that the RCOO R dash will have a power of 1, right? So you can see whenever something is in excess, I put the order as 0. You can even take it as a note in your notebooks. Whenever something is in excess, the order with respect to that particular component is 0, right? So for the same question, they have given A is in excess. So blindly you can put A's order is 0. So only you have to find for B's order. Find it out and tell me the answer. Yes, for how many of you this chapter has been completed in your school? Guys, have they started this chapter in your schools?
No, sir.
No, sir.
No, sir.
Okay,
In our school, sir.
okay. I forgot it. How was the test? I think there was one question, isn't it? There was one question which was incomplete. So for that, you don't have to answer. So it will be out of 37 marks, right? It is not out of 40 marks. It will be out of 37 marks. So yes, how was the test? Was it okay?
Yes. Okay, sir. Fine.
Yes, sir. It was okay.
Yeah, I think if you had have just listened to the class, right, you would have been able to answer all the questions literally very easily, isn't it?
Yes, sir.
Right?
Sir.
So hope you understood. Like, if at all, if you don't have the habit of taking notes while the class is going on, please start taking notes, right? So there are a lot of advantages if you start taking down notes. The one advantage is You don't have to go through that big book, right? So you know how many pages will be there for that particular chapter. But here, like even though the number of pages are high, you would have written in shortcuts, like you would have written in a way which you will understand, right? So studying, going through notes and understanding the concept is actually very, very, very easy when compared to going through the book and understanding, right? So if at all you don't have the habit of starting notes, please start it, right? It is actually going to help. So see, actually, when I was in your age, even I didn't have the patience to actually take notes. But now I realize, okay, if at all some effort has to be put, right? So having the brains alone is not sufficient, guys. That's the reality of the world, right? If you have the brains, right? If you're smart, but that's actually not enough, because like you, there are millions of students who are smart, who are good at work, right? Who are actually, so what is going to make you say stay above them is only the amount of efforts you put in, right? So if at all you think that okay, I am smart, I'll be able to do this, this is exactly what I thought, right? So if at all I would have actually channelized my whatever the smartness or talents in a proper way, maybe I would have there in still more bigger positions, right? So like this is your age, right? So when you maybe like, see, you can ask me, sir, I know you're talking like as if you're 40 years old. Exactly, that's the point. We are not that say we are not that we don't have that much age gap. Say what, you will be some 18, right? 17, 18. I'm just 25. It's been what, some 5 6 years since I finished my school, max 6 7 years, right? So I'm still, and I have been seeing students for the past all the 6 years, right from my college, right from my second year I started teaching, right? So I have been looking at students, like how they behave, what kind of problems they face, right? Right. So the thing is, you have to channelize, right? You have to channelize your whatever talents you have. Hey, you like, see, and I completely understand that studies is not everybody's cup of tea, right? You will not, not everybody will be able to score a 90 or hundreds, right? But the thing is, you have to understand what a talent is first, right? And accordingly work on it. But the thing is, getting some decent mark in your 11th and 12th now in India, at least it's very mandatory, right? So even though you have some other hobbies, some other desires, there is no chance, there is no option for you than to study this and at least pass 12th with a good marks, and then you can do whatever you want, right? So all this I'm saying is just for you to take down the notes, like go through it. And actually it is, I'm trying to make your job easier. That's what I'm trying to do. That's why you can see and you can understand that the way in which I'm teaching is actually entirely different. I don't teach like your school teachers, right? I actually want you to know what exactly is chemistry. Like I want to take you to the depth. Why exactly like this? I wanted to ask her, why not this, why that, how this, how that. All this, if you're gonna ask, I'll be more happy, right? So my way of teaching is not to get you score good marks. My interest is to make you love the subject, make you like chemistry, what exactly is happening, to the depth I should take you and make you understand, right? So I hope everybody is up for it, right? So if not, you can actually sit and think and make your head straight, right? And then come sit in the class, right? And please, it's a request from my side. Please sit with the notebook, and whatever comes out of my mind, mouth, and whatever I write on the board, it should be there in your notebooks. Again, it's not a compulsion that you have to do it, but trust me, that actually is going to help. You will save almost 4 times the time which you're gonna spend on your notebooks in your textbooks. Trust me, that is what is the truth. Okay. But anyways, so I think I was speaking. So now you can do the problem. Yes, any answers? It's a simple problem. just exactly like the previous problem. This much time. Or are you guys thinking about what I said? No, this is not the right time. After the class gets over, please sit and think. You have all the time in your world.
So I don't think I'm getting the answer, so it's kind of weird. It's not much.
Okay. Okay. Fine.
Same, sir.
Okay. Fine. I will do it. Okay. So, oh, I forgot. I wrote the reaction. Okay. It's 2A plus 3B giving products. This was the reaction, right? And they gave that this is an excess. So I can directly write the rate law as R is equal to Ka power 0. That I'll be able to fix because my A is in excess. So I have to find only the concentration for B. So say I'll keep it as N. That's what I need to find now, right? Okay. So now what they're telling that, so this is there, when the concentration of B becomes changes from 0.1 to 0.04, the rate is getting doubled. Say I put R1, say R1, I'll put the concentration of B as 0.01 M. So K into A power 0 into 0.01, the whole power N, right? And say R2, the rate is now, okay, now what is happening to R2? R2 is actually getting doubled, right? When I change the concentration of B from 0.01 to 0.04, all the other things remain same except for B as well as the rate. Now what is happening to rate? Rate is becoming doubled. So can I write it as 2R1? So when the concentration of B is changed from 0.01 to 0.04, the rate is getting doubled. So if it is R1, for 0.04, it will be 2R1. So I will divide this by this. I'll divide this. So K gets cancelled. A naught, A power 0 gets cancelled. So if I actually take the reciprocal, okay, actually divide this by this, it will be easier, right? So how can I write? Can I write it as 0.04 divided by 0.01, the whole power n. 0.04 divided by 0.01, the whole power n is equal to what? This divided by this, can I say it is 2? 2R1 by R1 will become 2, right? Okay, so now how will I write this? I can write this as 4 power n is equal to 2. 0.04 divided by 0.01 will become 4. So I have 4 power n is equal to 2. So what should be the n value?
1 by 2.
1 by 2.
Root of 4 is what is 2. So n is half. What was the difficulty here? Simple only, right? Okay. So you're going to get better. Don't worry. I'll give you one more problem. Okay. So if first take this down, I'll give you the question. I have not heard actually few people's voice. Okay, I'm gonna call out the name. At least you're gonna tell me yes, sir. I wanna actually Gabriel Jomar Emil. Are you there? Gabriel? Okay, some problem maybe. Mridula, are you there?
Yes, sir. Yes, sir.
Okay. At last, first time. Okay, thank you, Mridula. Sri Nivedita.
Yes, sir.
Okay, fine. First time voice heard. Okay, so next is Taran and Tarun, both of them.
Yes, sir.
And Tarun?
Yes, sir.
Okay, fine. Lastly, Varsha. Varsha?
Yes, sir.
Okay. Fine. So there are a few more, but I'm not getting maybe Lakshanya. I think I've heard Shruti Devasenai. I think I have heard. So yes. So guys, please ask your doubts. If at all, the thing is, like I will anyways be entertained because I'm teaching, right? And someone will be asking something. They'll be talking with me. But if at all you don't want to get bored, right? Just looking at the camera, just looking at the phone will be sometimes a little boring. Please engage yourself. Even if it is going to be a stupidest doubt, nobody is going to judge you. At least I'm not going to judge you, and I am not going to let anyone judge you. I will make it a promise, right? So you don't. Okay, Shruti Devasenai is raising her hand. Do you have any doubts, Kana Shruti? Okay. So anyways, so the thing is, please engage yourself, right? You can ask any doubts here, like even the stupidest of doubt. You don't know, like actually you don't know whether that particular doubt is stupid unless and until you ask it, right? So please to go for it, right? So this I understand, this I didn't understand. Please explain me again why this, why that. Is all your rights. You can ask. Okay, fine. So hope everybody got the answer. I'll go to the next question. Right. Yeah. So the question goes like this: the rate law for a reaction is given by the rate law of a reaction is given by the rate law of reaction is given by R is equal to K A power N into B power M. Right? The rate law of a reaction is given by R is equal to K A power N into B power M. Okay. If the concentration of A is doubled, if the concentration of A is doubled and that of B is halved, HALVED, right? If the concentration of A is doubled and that of B is halved, find the ratio of the new rate and the old rate. If the concentration of A is doubled and that of B is halved, find the ratio of the new rate and the old rate. Basically, when the concentrations are not changing, that is the old rate. So when the concentration of A is doubled and that of B is halved, what is the rate there? That is the new rate. Okay, so they want to know R new divided by R old. That is the new rate divided by the old rate. What is the ratio? Can you do it? So you obviously will be getting the answer in terms of N and M. You don't have to worry about there are not numbers. I just get the answer in terms of N and M. That's what you will get. Yes, please give me the answer.
Sir, I'm sorry, could you repeat the question?
Yeah, sure. So the rate law of reaction is given by R is equal to K into A power M into B power M, A power N into B power M, right? Now the deadline, if the concentration of A is doubled, and that of B is halved, if the concentration of A is doubled and that of B is halved, find the ratio of the new rate and the old rate. Find the ratio of the new rate and the old rate.
Sir, is it 2 for M by N?
2 power
M by N.
N by M? No.
No, sir, M by N.
M by N also? No.
Sir,
I think
1 by 2 power N minus M.
1 by 2 power
N minus M.
N minus M. Okay, almost getting there. So I think the guy who told me the answer, I think you did everything correct, but you're a little poor in mathematics, Kana. Right? When you bring the powers from the denominator to the numerator, what will happen?
Oh, okay, sir. M minus n, sir.
Correct. So anyways, so we'll look into it. Anyways, I'll give you some more time. I'll give you 1 more minute. Let me see anybody else is giving me the answer.
I have a doubt, sir.
Yeah, Kanna, tell
So
me.
for this question, we have two answers, right? So it can be 1 by 2 power n minus m or 2 power m minus m.
Correct. It can be anything. It can be anything.
So if we write any one, will we get marks, or we should?
Yeah. Anything, anyone, you get the marks. But it is better to write it as 2 power something. Like that will look better to look like basically to look at it. It looks better. But anyways, both the answers are correct. They're not going to cut marks for you. Like that.
Yes.
No.
Yes.
Yeah. Right. So again, say this is my old rate. Like nothing is changing. That's the concentration of A and concentration of B is there. Right. So R new will become what? K. Now what is happening to A? A's concentration is getting doubled. So I'll write it as 2A power n. And the concentration of B is getting halved. So I'll write it as 1 by 2 power n. Done? Right? So now what I have to do? I have to divide this by this. Right? So R new divided by R old, KK will get cancelled, AA will get cancelled, BB will get cancelled. So what do I have? I have 2 power n into 1 by 2 power m. This is what I have. So obviously I can write 2 power n into 1 by 2 power m. How can I write it as? I can write it as 2 power minus m. Right, 2 power minus m. So now both the bases are equal. So what will happen? It will be 2 power n minus m. This is the answer. Easy, right? So this easily you'll get 2 marks easily like that. This question, and definitely one question is going to come in your board exams from this. Right? Okay. Right. What is the time? We have time. Okay. So one last question. Right. So if you have taken this down, we'll do one more question. Right. So hope everybody took down everything. Okay. So the question goes like this. So for a reaction 2A plus B giving products, right? For a reaction 2A plus B giving products, they have given some table, right? So the table goes like this. I have A naught, B naught, that is these are the initial concentrations, and the rate of the reaction, right? So 0.1 m and then 0.2 m and 0.1 m. And then for this, it's 0.1 m, 0.1 m, 0.2 m. So the rates are 0.25. Here it is 0.50. Here it is 0.25. Right. So this data is given to you. So they're asking you find the rate law. Right. Find the rate law of this reaction. Right. So this kind of problem, this is a very smaller data. A bigger version of this can be even asked in your 5 marks, right? They would have given still more data, so many data they would have given, right? And they can ask you to find the same thing, the rate law, right? Okay, we'll see that later. For now, this is just a what is it? Trailer, right? Yeah. Right. So I'll tell you how to approach these questions. Then say from next question you will be able to answer it, right? So the first thing is for us to look at whether any of the reactant has no role to play. Like basically, what do you mean by no role to play? If it is very easy for us to identify whether one of the reactant is having an order of 0. Or when I have order 0, that means what? That means it does not affect the rate of the reaction. That concentration is not affecting the rate of the reaction. So like that, we'll try to see, right? Say now, you see here, when the concentration of A is becoming from 0.1 to 0.2 m, right? When it becomes 0.1 to 0.2 m, what is happening to the rate? Rate is also changing. So definitely there is some power coming for A, no doubt about it, right? So when the concentration is changed, the rate is also changing. Done. Okay. When I go to B, we'll see what happens. Say here the concentration is 0.1 and here it is again 0.1, so we cannot compare. I will go to the next data. So 0.1 to 0.2, it is increasing. But see what is the rate? 0.25, 0.25. That means what? That means that the B's order is 0. Why? Because when I'm saying that the concentration is changing for B, there is no change in rate for the reaction. Right? That means what? B has no role to play in deciding the order of the reaction. That means what? B's order is 0. It does not affect the rate. Right? So one thing you'll be able to easily write, R is equal to K, A power something like A power X that we will find now, and B power 0. Again, repeat, why B power 0? When the concentration is changed from 0.1 to 0.2, I see that the rate is not changing. And you know how the graph looks for a 0th order reaction. It looks like this. That means the rate becomes constant even though the concentration is changing. Right? So from this I can understand that the B's order is 0. Done. Right? So I have to do only for A. Right? Now can you do it? Tell me the answer. What is the X value? Can you tell me? So obviously you have to take the data very properly, right? Say first, like if at all you see that this thing is not 0, that is the B's order is not 0, this is how you approach the question. Say first, you have to look at the data, right? And you're like whenever you write the rate law, make sure one of them is changing and the other one is constant. For example, in the first step, I will see that 0.1, 0.2, A's concentration is changing. And here, if in the first two things, the B's concentration is not changing. So I will take this and write the two rate laws, find the order with respect to A, right? If at all I want to find what is the order with respect to B, I will make sure that the A is constant. That is, I'll take the first and third iteration because here the A's value is constant and B's value is changing. That is 0.1 to 0.2, it is changing. So now what will happen? If now I have to take A's will get cancelled, I'll be able to find what is the concentration in order of B. So anyways, we'll do more problems like this. Now for now, it's an easier problem. You can already found out what is the order with respect to B. B's order is 0. Done. So I have to find only for A. So first, take the first two iterations, write the rate law, and cancel and divide it. You'll be able to get what is the X value.
So N is 1/2.
It's 1/2. Okay, we'll check. Right. So now I'll write it like this. R is equal to, for the first iteration, for this I'm writing. I don't even have to include B in this. It's not required. So I'll write R is equal to, okay, R is given. R is what? 0.25 is equal to K into A power, that is 0.1 power some X. And I have to find this. Same way. Going to the second iteration, the rate is 0.50, right? K. And what is happening to the concentration? Concentration is 0.2 power X. Right? Okay, now I'll divide this by this. Right? So I have 0.5 divided by 0.25. KK will get cancelled. So I have 0.2 divided by 0.1, the whole power X. Right? So 0.25 and 0.5 will become 2. 2 is equal to same way 0.2 by 0.1 become 2. So 2 power x. So what should be x value now?
1.
1. That's it. 2 power 1 is 2. So how will write the rate law? Rate law is going to be like this. R is equal to k a power 1 into b power 0. This is the answer. Right? Simple, right? I just took the first 2, 0.1. I mean, first the rate is 0.25, k into 0.1 for a. For second one, it is 0.5, the rate, k into 0.2, the whole power x, I divided, got the x value. Very simple. Right? So we'll do a bigger version problem of this in the next class, because it might also, and I have almost seen every question paper like this kind of question coming in at least in 3 marks. The table problems like this. Okay, so we'll see that in the next class, right? So guys, any doubts? Everybody understood everything?
Yes, sir.
Right? Okay, fine then. Yeah, thank you. We'll meet again day after tomorrow.
Thank you,
Thank
sir.
you.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah, thank you.